Hello everyone, this is a projector, Nexigo, model number is a PG40, 160 watt. So the customer said he heard the loud pop. After that is completely the device dead, no power at all. So I'm not gonna plug it in. I'm gonna check it apart and look to see if we can see any smokes, cracked component, burned component, and we go from there. Alright, the device is apart, and this projector doesn't have the DLP. This is a LCD projector. So there is a LCD screen. There is no backlight, or the device has no power. We're gonna go and check the power board. Well, the first thing you can see this capacitor and this capacitor. This is look like it's swollen a little bit. Alright, we have a MOSFET over there. This is a switch in power supply, and it look like that's the LED lamp power. This is the input power. We have one fuse right there. Alright, the fuse still good. And we have a filtering coil, and we have a rectifier bridge. Yeah, there is no short in the rectifier bridge. Then we have two capacitors. From that two capacitors, okay, that's a resistor. Yep, the resistor is here. So look like that's a switch in IC. That's a resistor for the source. The positive side is go direct to the transformer. The negative is go to the resistor, a low ohm resistor for the source. This should be a low ohm. That resistor is open. And we have a MOSFET. The MOSFET is shorted completely. And I think this resistor here is bad. This resistor here is bad. So we have optocoupler, and all we have is these two outputs. No, where is the output? Is here. Is the negative side of the. Let's see the optocoupler if it's connected to the ground. Yes, the hot side ground. So basically we can use the, because right here we're gonna need all these components. I don't know what resistor is there. I see one resistor is burned. Yeah, I'm not gonna bother replacing all these components. In the end we are gonna find wrong voltage, or as there is no schematic to see this burned, small burned resistor over there. Yeah, it's completely burned. So the optocoupler is, this side is ground, plus we're gonna need to replace this capacitor. Alright, let's do it. Alright, let's discharge this capacitor and we check it as well. These capacitors here, all of them is a low ESR. Good. 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 The VCC capacitor, that's good. But this one, I check open. Yeah. Even this one, the one is bad, is completely open. Yeah. So that's capacitor is bad as well. It looks good, but it's completely open. Yep. The capacitor was leaking. You can see that. Alright, this capacitor is 100 microfarad, 400 volt. We need two of them. Alright, I do have these two capacitors. Is 450 volt, 100 microfarad, and let's check the ESR. Very low ESR, better than new. Very low ESR. It's a little bit, like about 5-6 millimeter different. I think there is a space for the capacitor. Yeah, there is enough space. Alright, so we'll replace the capacitor and we're going to need to remove the switching IC and the MOSFET. Right, I'm still going to use this one as a heatsink for this one here. And I need to check that resistor as well. Yep, that resistor is burned. That was 0.1 ohm. Yep, I need a resistor for the source. Yep, I'm gonna get a resistor for the source. Then we can look on this board. So the resistor of the source, you find them like close to the, like this one over there, 0.2 ohm. But it's a little bit small size, I need something bigger. Yep, I find some close size. Anything under 1 ohm, it will work. Doesn't need like 0.1, 0.234, it will be fine. Okay, so now we can start putting this one. So the yellow is the drain. The drain is mean the output of the MOSFET. Okay, that's the gauge because it's connected to the IC. This is the source and should be that's the drain. And this will connect direct to the transformer. The black is the ground which means we can even connect it to here, or we can connect it to the source of the MOSFET. The red is going to be to the VCC, it's mean to the positive side of the capacitor. Is the to the optocoupler. This is the ground, so let me see just to be sure. Okay, that's the ground, so we should connect to that one. Yeah, this far side is the ground, and this is the feedback side of the optocoupler. Alright, like that. And the green is going to go to the positive side of the capacitors. So where is the positive side? Yeah, you want all the wires to be in this side, because the board is sliding. Here. So, and I flip the resistor, that blue resistor, and I solder it in the top of it. Because that resistor is connected to the positive side of the two capacitors. The positive side is right here. So let's plug the board. So that's the output. Here, 13 volt. That's the LED connector. It's gonna work when the projector is on. So let's plug it, and hopefully everything is work. Yeah, this module is very handy for the power supply. Any repair shop should have a couple of them in stock. I think that's the last one I have here. I always order like 10 of them. We have the blue light. Projector is on. And it's gonna go off. So let's see. That's the power button. Let's go on and off. Why? Oh, could be should be like there is a sensor for maybe. Maybe there is a sensor for the cover. I did see the lamp flashing, but we need the lamp to stay on. Yeah, the power supply, it works, but and the projector turns on, then goes off. So there is another issue with this one. Could be the LEDs is bad, but let's check it more. Yeah, with this module, as you did see, we have the output voltage is good, 12 volt, and the device turns on like 1 second, then goes off. It goes off right after the LED light turns on, then everything goes off. And it has this resistor to switch from 12 volt to the 24 volt. So this circuit is only give the output 24 volt or 12 volt. Right now it's set up at the 24 volt. These two resistor here set up at 24 volt. If we want to switch to the 12 volt, we need to move this one to here and move this one to here. And that time, this module, it will be ready for the 12 volt. All right, that's the diagram. And we have the black line is connected to the ground of the capacitor, the hot side. And we have the red line, the red wire is connected to the drain of the MOSFET. The black wire, we can connect it to the source. So this is the source, this is the drain. This one is connected to the output of this diode. That's the output of the cold side, 12 volt or 24 volt. That's the yellow line, the positive yellow line to the output. And the white line, it will be connected to the negative side of the cold side, the output, negative side. And the green wire, it will connect it to the VCC. That should be connected to the VCC. All the feedback circuit, it will not be in use because we are going to connect the wires to the output that will be taking the feedback. This module, it will require the voltage start. So we're going to need to check if we have the voltage start in this board. The voltage start, you can locate it at this is a VCC capacitor. The VCC capacitor, and there should be a diode next to it that's connected the VCC coil. It should be this one. This pin here is the VCC coil is connected to this diode, then connected to the capacitor. The positive side of the diode, it should be connected with a resistor, big resistor, to the positive side of the big capacitor. And this one's here. And that's how we check the voltage start, not VCC. So if we plug this one, and we have like between 10 and 20 volt by the output of the diode, is mean we have the voltage start. If we don't have it, then we're going to need a resistor to get that voltage. So let's check. All right. So that one is the ground. We just have 0.2 volt. This means we don't have the voltage start. All right, let's drain the capacitors. All right, the capacitors are good. So I'm going to use this resistor. It's from a power supply. It's the same. It's for the voltage start. Is 2 and 5. So this is 220 kilo ohm or 0.2 mega ohm. And this is the positive side of the big capacitor, the hot side, this big trace. And I'm gonna connect it to this trace because it's going next to to the diode, the positive side of the capacitor, the VCC capacitor. And I can make a jumper over there. This trace, it was going to the switching IC, the original IC, that is not in use anymore. So we can use this trace for our voltage start. Just right there. And that trace, we're going to use it for the voltage start. It's connected to not on the other side. It had couple resistor here that was using by the switching IC, but I removed them. So I can make a jumper right here. Alright, just like that. Okay, so you can see I connect the positive side of the capacitor to the voltage start resistor. So let's plug it and see if we have the voltage start now. So let's see, I did have some voltage. Just want to be sure. It's a 72 volt. That's a little bit high. Because it's not connected to the VCC, that voltage will look high, but it will go down when we connected the module. Yeah, that's the power in this line. It has a high voltage, but it's very low with the big resistor. It will drop when we connect the module. This MOSFET is not connected to this heatsink because this MOSFET, it has this metal. It shouldn't touch the heatsink. They put this bed right here, so don't forget to put that bed before you put the MOSFET to the heatsink. And let's start pulling the wires. So the black and the red, it will go, black it will go to the source, this side here, and the red to the drain. Red to the drain. The green is to the VCC. Yep, to the positive side of the capacitor. The white is to the negative side of the output capacitors. So let's see what is the negative side. We can take it from this capacitor, and this is the cold side, and that's the ground. Yeah, I want to connect everything to this side of the board. So I'll show you some. And the yellow, it should connect to the positive side of the output. Can be connected to this diode, but here is kind of hard, but I can connect it. So to this side, which means I'm gonna clear that hole so I can get the wire to it. Okay, let's check again. The black wire to this from the source. The red wire is the drain. That's the drain, and is connected to the transformer. That's the red wire. The yellow wire is to the positive of the output. The white wire is the cold, the output ground. The green is the VCC. Yep. I remove the resistor to the 12 volt position. So this resistor is moved to the next one, and this resistor is moved to the next one. It's a 0 ohm resistor. If you lost that resistor, just make a jumpers. Yeah, let's plug it. Okay, let's see the output. And here we have 12 volt exactly. And the voltage start 9 volt. You remember it was like 70 something because it was no load in it. So yeah, let's put it in the device, and hopefully the lamp is stay on. Put the power supply in the place over there. Let's plug the power. The blue light is on. Then it will go red. That's good. Now we press the power button. So the blue light is on. And we have, look, the lamp is staying on. Okay, let me see if you can see it over there. Yeah, right there. Here. See it in the... Yeah, it looks good. So that's all for this video. Thank you for watching, and see you again.